Good evening, my name is Beth McLean. I assist Dr. Victor Fishman, who is the head of the Washington office for the Applied Research Lab of Penn State, and we're actually located in Arlington, Virginia. We're able to host these seminars this evening because of sponsorship by the Department of Navy, specifically the Office of Naval Research. Their acronym is ONR, and they are also right around the corner from our office in Arlington, Virginia. If we were to choose one word to describe what we're trying to do this evening, it's exposure. Exposure of career and Navy civilian STEM employment opportunities through this first seminar this evening, Foundational Skills, and a seminar which is the second one in the series, which will be next Tuesday, the 13th. And that's a little more technical and a little more description of the opportunities that would be available to you. The gentleman that will be describing that will be providing that seminar actually work at the warfare centers, one in West Bethesda, Maryland, and the other in Philadelphia, Pennsylvania. And they will be giving you specifics on what they do for the warfare center so that you can have interaction with someone who actually physically works there. Delivering tonight's presentation is Dr. Joe Corrado. Dr. Corrado worked at the Warfare Center or its predecessors for over 36 years, and he retired in 2004 and came aboard with us at ARL at that time. His career started in 1971 with Naval Ship Research and Naval Research and Development Center, and he was assigned to Research and Technology Directorate at the Naval Ship Systems Command a year later. He also served as the Technical Program Director for Surface Ship and Submarine Exploratory Development Programs, and later served under the Office of Director of Navy Laboratories. I think personally from reading his bio, one of the most interesting things that I have found out that he has done is his department helped to establish an unmanned vehicle, and it focused on autonomous operations, and maybe he'll tell you a little bit about that this evening. And as I said before, in 2008 he retired after 36 years of public service. So Dr. Corrado? Sure.
As Beth pointed out, I spent 36 years at the Carter Division. I'm not going to ignore you people over there, but the bulk are over here, so if you want me to talk to you, you might want to move over here, but if you're more comfortable there, that's fine. Yeah, and it's been a tremendous career. I've enjoyed every minute of it. Lots of technical challenges, a lot of smart people that you rub minds with. I got my bachelor's degree from the University of Detroit, my master's and PhD from Lehigh University with a major in structural engineering. Went right from there to actually work 2 years before I went to the Carter Division. I spent 2 years between my master's and my PhD at the Electric Boat Division of the General Dynamics Corporation. Those are the folks that build naval submarines. One of the major shipbuilders for naval submarines is the Electric Boat up in Groton, Connecticut. And so I'll probably stop there with background unless you have some specific things you want to know later. And as Beth pointed out, this was funded, this initiative on naval foundational skills was funded at ONR by Dr. Anthony Jr. The initiative actually was a joint effort between the Carter Division and ARL Penn State. You'll see as I go through this presentation a lot of acronyms. I will try to remember to tell you what the acronym means the first time you see it. If I don't, call timeout. If you want to know what it means, then I'll explain what it means. Secondly, if you have any questions during the course of the presentation, don't hesitate to ask. You don't have to wait till the end of the presentation to do that, okay? So those are kind of a couple of the ground rules going forward. This next slide, just for your information, provides some context. If there are some questions you have after this is over, you go back to your dorms or whatever, you could contact any of those people. There were business cards in the back you could have picked up. This is in your handout, so you have the contact information that you need. So what's the objective? Beth sort of touched on that, to get you exposure to the Navy environment. It's graduate, you're, I guess, all participating in as graduates ready for tasking. Is that true? Do you know what that means? Maybe not. Anyway, it's, the words mean to get you folks familiarized with the Navy so that if you choose a career with the Navy, you're not going in cold. You'll have some background on it. You'll have some background, some fairly high levels, and also a little more, we'll drill down from actually the Secretary of the Navy down to where the work gets done in what we used to call laboratories, like the Carter Rock Division. And these are the kinds of topics we'll be covering: the Navy's organization and responsibility, a component of the Navy called the Naval Sea Systems Command, that organization and responsibilities with a focus on ship design and acquisition, and also the organization responsibilities and technical capabilities of one of the warfare centers which are part of the Naval Sea Systems Command. And then we'll talk a little bit about career opportunities. So that's kind of what we're going to cover. This next slide is just to acknowledge that there have been other people involved with PEO, stands for Program Executive Office, and that's Program Executive Office Ship. So those folks located in that organization, and this is Carter Rock's acronym, NSWCCD. So it's Naval Surface Warfare Center, Carter Rock Division. That's what those stands for. So we didn't do this by ourselves. We had some help doing it. This is the outline. I think I've touched on most of these things, so I won't dwell on it. And we're going to start off then with the Department of the Navy. Again, this is an organization chart. This is not the total organization chart for the Department of the Navy. This kind of lays out the things, the important things that I want to touch on this evening. The highlighted areas are I'm going to talk in more detail. You'll notice that the commander, sorry, we're using a pointer instead of a laser, but my laser kind of crapped out. So we're talking about the commander of the Naval Sea Systems Command, which comes under the Chief of Naval Operations. We'll touch on these program executive offices, organizations. This is not a complete list. These are the 5 that are affiliated with the Naval Sea Systems Command. And the Naval Sea Systems Command is only one systems command out of several. You'll see the list of those later on. So that's what we're going to touch on, starting with the Secretary of the Navy. Okay, current Secretary of the Navy is the Honorable Ray Mabus. He's been in that position, well, at least since the current president took office. Secretary of the Navy was established by a congressional code. The person in that position has to be nominated by the president and has to be confirmed by a majority of the U.S. Senate to take that particular position. Just a little history. Prior to 1947, the Secretary of the Navy was actually a member of the President's cabinet. It wasn't a separate department, the Department of Defense. He or she is responsible for all the affairs of the Department of the Navy, and there's a list there showing that. So now let's switch to the Chief of Naval Operations, who reports directly to the Secretary of the Navy. Okay, he is the current, and we use the term, abbreviated term CNO, Chief of Naval Operations. Some of you familiar with this stuff? I'm just trying to get, yeah, okay, so hopefully I don't bore you too much with the basics, but I know some of you are probably not, okay. So it's Admiral Gary Ruffett. He's a 4-star admiral. He's the senior military officer in the Navy. He's responsible for the utilization, efficient utilization of resources and the operating forces. as well as naval shore activities. I'll touch on those a little bit. A member of the Joint Chiefs of Staff, and he's the principal naval advisor to both the President and the Secretary of the Navy. It's a pretty important job with a lot of responsibility. So again, here's his operating forces, okay? An organization chart of his operating forces, starting with the Atlantic Fleet, Pacific Fleet, then he's got a command in Europe that he's responsible for, one which concerns itself with the Mideast, and the Southern Command which concerns itself with Central, South America, and the Caribbean. So these are ships, sailors, aircraft on aircraft carriers, lots of people, lots of expensive equipment, lots of dollars tied up in the people and the equipment. So very major responsibility just for the operating forces. But that isn't all he has responsibility for. As this next chart shows, he's responsible for the shore establishment that's there to support the operating forces. These are the folks mostly in the U.S., but worldwide, predominantly in the U.S., that support all of those operating forces. And these are the systems commands I referred to earlier with the Naval Sea Systems Command, which we're going to talk about in more detail. You see the Naval Academy comes under him. Also, he's responsible for the Office of Naval Intelligence. Hundreds of thousands of people, plus all those ships I previously talked about and sailors. Awesome responsibility that the CNO has. Okay, I'm switching now to the left side of that first chart I showed you for the Department of the Navy. This is the Assistant Secretary of the Navy for Acquisition, Research, Development, and Acquisition, RD&A, they refer to it as. Current Assistant Secretary for RD&A is Mr. Sean Stackley. He reports to the Secretary of the Navy. He's the Naval's Acquisition Executive. We're talking about the person that's responsible for all the things the Navy buys to put out there in the naval force, the operating forces, the ships, the aircraft, the space stuff, the submarines, what have you. Any equipment that the Navy buys, he is responsible for. That's billions of dollars, responsible for billions of dollars. He has to also, in addition to procuring those systems, he has to take the requirements that come from the Pentagon, from the Chief of Naval Operations staff folks, if you will, and translate that into executable research, development, and acquisition programs. And that's a big responsibility. I'm not going to read all these things. ACAT just stands for acquisition categories. There are different acquisition categories depending upon the dollar amount. If you're buying something real big, there's an acquisition, expensive I should say, there's an acquisition category that pertains to that, and so on down you get some of the small items. I want to focus on this last bullet, if you will. He has the responsibility for assessing the programs and taking the action to manage program risks. As you'll see later, these are very complex systems. A ship system is probably the most complex system that I can think of. And I'll show you some examples of that. And there's a lot of risk associated with that when you're designing and when you actually go and build these warfare systems. And so he has to manage that risk. He's got a limited budget in most cases, which Congress scrutinizes to the nth degree. And so he has to manage that program risk. Very important, very difficult task. Here's an organization chart for the Assistant Secretary. Remember I mentioned these program executive offices? I can't reach up there. Anyway, I showed you 5 of them, the ones that were affiliated with the Naval Sea Systems Command. This is the complete list. So you can see there's command control and intelligence, space systems, unmanned systems, well, the aircraft carriers were on it. There's land systems to support the Marine Corps, if you will. So all of that, he's buying stuff, okay? There's the complete list of systems commands. The one we're going to focus on is the Naval Sea Systems Commands. And he has a bunch of people helping him, his deputies, but tremendous job. Hundreds of thousands of people, billions of dollars. Big, important job within the Navy, if you will. Okay, so let's now drill down to the Naval Sea Systems Command. This is their mission, okay, to develop, deliver, and maintain ships and systems on time, but most importantly, at budget or under budget. I don't think there are too many that come in under budget, but at least on budget. They're the largest of the 5 systems commands that was on that previous list. It has about 55,000 people associated with the Naval Sea Systems Command, and they're involved with the management of about 150 acquisition programs, if you will. There are 4 shipyards. These are government shipyards. I'll show you where they reside. 2 warfare centers. I'll talk a little bit more about them, surface and undersea. Within those 2 warfare centers, there are 10 warfare center divisions. There are 4 major shipbuilding locations. Those are private yards, like Northrop Grumman or Bath Iron Works up in Maine. But the Navy has to oversee those, and NAVSEA has the responsibility for overseeing those private shipyards when they are doing construction for the Navy. Their headquarters are located at the Washington Naval Yard in Washington, D.C., not too far from the baseball stadium of the Washington Nationals, if you will. You could walk there from the Navy Yard. Here's an organization chart. I'm not going to go through this again just to show you the breadth of this thing. The PEO organizations, and these are the 5 that are affiliated with the Naval Sea Systems Command. Those folks do not report to the commander of the Naval Sea Systems Command. They have additional responsibility to keep him informed. They report to the Assistant Secretary of the Navy for Research, Development, and Acquisition, the one I showed you, Mr. Stackley. But they reside physically over at the Navy Yard, the same place where the Naval Sea Systems Command resides. These are their functional directorates. I'm going to drill down later into the Systems Engineering Directorate, what they call NAVSEA'05. The government yards and the private yards come under this part of the organization. And these are the 2 warfare centers I'm going to talk to later. Okay? So I'm going to spend some time on this, show you these, these, and talk about the warfare centers a little bit as we go forward. Well, how does NAVSEA interface with the fleet? There definitely has to be some interaction. They're responsible for improving the material condition, whether it involves repair or maintenance or modernization. They're also involved in ship conversion. So if the Navy, excuse me, wants to change the mission capability of a ship, it would fall in the ship conversion category, and NAVSEA would definitely be involved with that. There is a focus also on coming up with ideas, technologies, what have you, to reduce the total ownership cost of ships, as well as reducing dependence on fossil fuels. So that's some of their responsibilities for the current fleet, the fleet out there, but they also have responsibility for building the future fleet. Doing ship development, concept exploration, design and engineering support, delivering the ships and the systems on time and on cost. They work with those program executive officers. Those are the folks that have the responsibility for acquiring those future systems. But NAVSEA is responsible for supporting them. And then they also have responsibility for the technology development, not all of it, but some of it, and transitioning the technology into those ship acquisition programs instead of putting it on the shelf. So they interface with both the current and future fleet. Here's just some of the ships. I threw this in at this point that they would get involved with. Up in the upper left-hand corner, is one of the support ships. Center upper is a destroyer. That's the Arleigh Burke class. Well, I'll show you a little more detail on that. These are two what we call littoral combatant ships, two different designs. There's a monohull and a multi-hull, obviously an aircraft carrier and submarines. So some examples of the kind of ship systems that they get involved with. Now don't laugh at this next slide, okay? I was asked to put this in there to give you some feel for ship nomenclature. And I'm sure most of you know these terms, but I'll go through them quickly. So if you're standing on the ship and looking forward with the pointy end, looking towards the pointy end of the ship, that's the bow. If you're looking back, at the back end of the ship, it's the stern. Again, you're still looking forward. On your right side is the starboard side, and on the left side is the port side, okay? That thing sticking up is called the mast. They mount antennas, radars on that type of a structure, if you will. This thing is the lowest part in the ship, the keel. When they're building the ship, that's what gets down first, and there's a ceremony associated with that called the keel laying ceremony at the shipyard. All of the bigwigs, a lot of the bigwigs show up for that. And then lastly, the bridge on this chart is where they control the ship from. Again, just a smattering handful of terms, lots of others you'll become familiar with if you choose a career with the Navy. Navy people would laugh at me right out of this room showing that chart. Anyway, okay, this I just threw in there. These are those other functional directorates under NAVSEA. I'm only going to talk to the Systems Engineering Directorate, but before I do that, here's the 4 government shipyards, okay? One out in the state of Washington, around Bremerton, Washington, called Puget Sound Naval Shipyard. One in Kittery, Maine. One down in Norfolk, Virginia, and another out in Pearl Harbor, Hawaii. Again, no new construction gets done these days at the government yards. That usually gets done at a private yard, private shipyard. Any questions up to now? No? Okay. Okay, now, again, we're drilling down further. So now we're looking at the Systems Engineering Directorate under the Naval Sea Systems Command. And again, this is not a complete organization chart. This is put together to highlight a couple of parts of this organization, if you will. On the left, you have the folks called the ship design managers in blue. And on the right, you have the folks called the subject matter experts, okay? And both sides, these folks are warranted. Warranted meaning they have the responsibility, the authority, and they have to basically guarantee that the ship as designed and built is going to function as opposed to function. That's their responsibility. So these folks work closely with the folks in the program executive offices that they call them the program manager that are responsible for acquiring the ships. These folks support them. I'm going to talk a little bit about the right side first, the technical warrant holders, and then come back to the warranted ship design managers, if you will. So what do we mean by technical authority? That's kind of shown here. What is it? It's the authority, the responsibility, and the accountability to establish, monitor, improve technical standards, tools, processes, what have you, that conform to DoD and Navy requirements. What does it do? Again, it basically guarantees, it assures adherence to those standards and policy, and they provide, in doing that, they provide, hopefully they provide several technically acceptable alternatives, but with respect to risk, doing risk and value assessments. But it is not, I want to emphasize, the programmatic authority. They do not have the responsibility for the acquisition of those ships and ship systems. They don't have the contract authority and they don't have the legal authority. That resides in those program executive offices. We need technical people like you coming on board to fill these kinds of positions, these technical warrant holder positions, the subject matter experts. Those are the kinds of people that do this type of function. within the Navy, a very important function. So think about that. Here's kind of here's another listing of the responsibilities associated with technical authority. One I want to point out, which didn't come up on the other slide, is they're also responsible, the organization that has the technical warranty responsibility, to do the stewardship for the engineering and technical capabilities. So they have to go out, like we're doing today, and bring in the people like yourselves. So they're stewards for those technical capabilities which reside in people like you. So the change comes from the Secretary of the Navy down to NAVSEA to the directorates like Systems Engineering Directorate, and then the warrant holders come under there. There are about 200 in the Naval Sea Systems Command warrant holders, and they're supported by engineering managers and lead engineers. Many of them, not many of them, but some of them reside in the warfare centers. They don't necessarily have to reside at the Naval Sea Systems Command. Okay, we're going now to the left side of that chart, the things that were highlighted in blue. The ship design manager, the warranted ship design manager. He has to be dedicated to the program. What I mean is if there's a PEO office for like these littoral combatant ships, he has to be dedicated to that program and support that program manager. He has to build a team, a multidisciplinary team, because there are all kinds of technical issues associated with a ship system. He has to constantly maintain dialogue with the program manager, update established design practices and technical policies, and assist the program manager working with the shipbuilders and the design yards, if you will. So his chief objective of his team is to support the engineering needs of the program and the program manager and meet the program manager's priorities. Okay, this lays out several phases of ship design, starting with concept studies, feasibility studies, which are mostly done in-house with some contractor support. Then it goes over to the Center for Naval Analysis. That's a separate organization. It's not a government organization, but it strictly supports the Department of the Navy, do things like missionary analysis and looking at analysis of alternatives, alternative concepts to do the mission that is required. From the concept studies, they go into preliminary and contract design. I'll talk about those milestones later, where they occur in time. MS stands for milestone. Whether it's a warship or an auxiliary ship, it's usually done by the industry in the private sector. However, NAVSEA has the responsibility to evaluate the designs because they're usually competitive designs, and then make the selection of the lead shipbuilder. Once that step is completed, then that lead shipbuilder goes into detailed design. And again, that's done by the private sector primarily. There are some examples up here. For the DDG 1000 destroyer, which I'll show you, it's Bath Iron Works with Northrop Grumman and Raytheon and BAE Systems are all involved with that. However, NAVSEA does get involved in providing, GFE stands for Government Furnished Equipment, if you will, government furnished information. They also preview and approve, this is contract data requirements list that comes in with the contract and supports the integrated product teams that cut across both government and the private sector. And they help to resolve any shipbuilder problems, questions. No matter how the acquisition reform shifts, and it shifts regularly, both the Navy and industry have roles in it. Back about probably 10 years ago, there were those of the opinion that you ought to give everything to industry. Just set the requirements in general and then turn everything over to industry. Well, they tried doing that. That didn't work so well. And so now the pendulum's swinging back in the other direction, and the government's taking on a bigger role in the acquisition process. Okay, so ship systems, what I want to point out here, it's system engineering at all levels. Whether you're down here in the element of equipment that goes on a ship, or the weapon system platform, the combat system, like a gun if have you, or the combat system itself, the radars, up to the total ship system, and then looking even beyond that to the total force. What's the force makeup we need to do? We need to do the various missions. They're all done in a systems engineering manner, if you will. So it takes place at all levels, systems engineering. Okay, we're getting into showing you that why these ships are very complex. Starting from the bottom, level 4, you start out with a main reduction gear. That's, I guess, to some that might be not so complex, depending on that design. That piece goes up into this subsystem, if you will, and then that goes up into perhaps the propulsion system for the ship, and then those subsystems are put together into the total ship system. Starting down here with this, that's only one element. There are millions of these elements that have to go into making up those subsystems and systems that eventually constitute the total ship system. When compared to other products, aircraft, spacecraft, automobile, the ships are huge, okay? Carriers, 100,000 tons, if you will. They're complex, they're multi-mission, people have to live in them. They operate in a hostile environment. The marine saltwater environment is very unforgiving. They have extremely high cost per unit, from hundreds of millions up into the billions. I'll show you some information on the length of design and build times, as well as the service lifetimes. Low quantities, so we typically don't build hundreds of these, if you will. We're building a class of ships now, 3 ships. There are some, I'll show you the service lives that you expect out of these systems. It varies from ship to ship. There are unique industry issues. Usually there's not a commercial market for the kinds of stuff that these shipbuilders do. There have been attempts to make that happen, but usually these shipyards are uniquely building military warfare systems. There are no prototypes, so you can't go out there and play around with this thing, test it, and then come back and redesign. The follow-on ships are awarded, so they're starting to build the follow-on ships before you finish testing, non-destructive testing, the lead ship. So if you're screwed up with the design of the lead ship, perhaps you got some of those same problems with follow-on ships. And that costs money to make those fixes. And as I said, the testing of any of these things is non-destructive. We don't test them to failure. I think I said all of this, so I'm not going to repeat it except for this last bullet. There's intense congressional oversight because these programs are so expensive, and because they involve hiring people in congressmen's districts. So they have to deal with that. A couple acronyms I'll point out. There's Operational Requirements Document, Capability Development Document, and Capability Production Document. Okay. So what's the time frame it takes to get from the concept studies to actually delivering the lead ship of a particular class? So what we have on here, those are those milestones when they occur in time. That was on a previous slide. Across this is the requirements. That's an initial capability document and the concept development, capability development document. These are the phases we talked about. This is the kind of funding that the Navy uses to get them through those various phases. This is research and development. These categories are categories that Congress established long ago, 6.4, 6.5. SCN is another category of funding standing for Ship Construction Navy. And then this is the timeline. So for these concept studies, you're talking about 1 to 2 years. The analysis of alternatives, feasibility, 1 to 2 years. preliminary design, contract design 2 years, and then 5 years to do the detailed design and construction. So you're talking about a period of, I don't know, 10, 12 years. Actually 9 to 11, I guess, at the top of that chart. Okay, how about the service life? So there's a lot of stuff that gets done in system development, in R&D, before you actually get to doing any design work, if you will. So this is the time frame to do design, construction, and lead ship delivery. Follow-on ship production and service life. So you have the length of time across the top of this, typically 5 to 15 years for this, for the systems development, 10 to 15 for the design, construction of lead ship, 10 to 20 years for the follow-on ship, if it's not just 3 ships, okay? And then service life anywhere from 30 to 50 years. It's a little bit different, a little bit shorter, those time frames for this LCS, which is the littoral combatant ship, which I'll show you. So 55 to 100 years. It's a long time. Here's an example of a ship system that was out there from 1945 to 1991, if you will. 50 years for that carrier, which is now obviously mothballed. Long time frames for these ships. Okay, a little bit about cost, life cycle cost, just to point out what you do up here early on, whether you're talking about system development or even concept development, affects 80 to 90% of what it costs you to procure the ship and to operate the ship over its lifetime, operate and support it. These are kind of the investment. What you have plotted here is the 96-year dollars in millions, so we're talking about 10-year dollars, so they're not adjusted for inflation. So if you're looking at the top number, that's $6 billion, if you will, okay? And then the years, but you only invest about 2% of the total amount, total ownership cost on this kind of stuff. And most of it's spent on procurement and O&S. So you better do this stuff right, because it's going to have an impact down the line. Okay, a little bit about funding. Everybody know what a fiscal year is, when it begins, when it ends? No? It begins October